one thing about our trig functions, they are all what we call periodic functions. A periodic function is something that repeats. Oh, I don't want to highlight in black. That repeats after a certain amount of time. That length of time it takes to repeat is called the period. What do you think the period of sine and cosine would be? If you think about, after you go around the circle, don't you have all the same values again? How long does it take to go all the way around the circle in terms of radians? 2 pi. Sine and cosine are periodic functions, and their period is 2 pi. That is how long it takes before they begin repeating themselves. Anytime you want to draw a graph and you don't know what it looks like, we can make a t-chart. So that's what we're going to do. Do this on that handout I gave you. We can put in a lot of points. We could technically graph every point on our unit circle, but I'm just going to graph these 5 points and see if we can tell what the graph looks like from that. So we are looking at sine of theta. So what is the sine of 0? 0. Sine of pi over 2, that's like 90 degrees. 1. Sine of pi.
0.
3 pi over 2.
-1.
And
0.
2 pi is like 0 back to 0. Okay. So on my graph, my high point here is 1, my low point is -1. Then my x-axis are these angles. My 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I plot these, I've got 0, 0, pi over 2 is 1, pi is 0, 3 pi over 2 is -1, and 2 pi is back to 0. Now we can graph all the other points in between, but these are the main ones that we will use to get our graph. Now this graph, when you draw it, these are not straight lines. It's not a zigzag. This is a curve. And if we had plotted more points, that would have been obvious. Kind of overshot my point there.
Are these lines continuous?
Yes. So I only graphed it between 0 and 2 pi, but you could keep going around the circle, couldn't you? So this doesn't really start and stop here. It's what's called a periodic function, which means it's just going to keep doing the same thing over and over. And so it's just like a wave. Forever and ever, it's just going to bounce back and forth between -1 and 1. What we graphed here was a single period, because after you get to 2 pi, it's going to start repeating what it was already doing before. I shouldn't have touched that. So I graphed one period of the function, but we could graph more than one if we just extended this. The domain of that, if it keeps going forever in both directions, what is our domain?
Negative infinity, positive infinity.
Range. What y values do we hit?
-1 and 1.
Yeah. If you remember back in chapter 1, we talked about the domains and ranges of these trig functions, and that was the same thing we wrote down then. The smallest sine ever is -1, the biggest it ever is +1. What's wrong?
I don't do well with graphs, so
Don't be scared. This is, in general, probably the easiest chapter of this book.
I like graphs because you can actually visually see the math versus you reading words.
That's true. Do you not a graph person? So you guys may not like this chapter then if you guys aren't graph people, but it's not bad, I promise. This is just a picture showing what it would look like if you continue. This would be 2 periods of it, 2 cycles. Okay, let's do cosine. So we're going to do the same thing. We'll plug in these values. So cosine of 0, cosine pi over 2,
0.
cosine of pi,
-1.
3 pi over 2,
0.
and 2 pi.
1.
Do you guys know where these are coming from? Our values, or if you think about a unit circle, it's the x values. So 1, 0, -1, 0. All right, so again, I need a high point of 1, low point -1. These would be my pi over 2, pi, over 2 and 2 pi. Cosine of 0 is 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is 0, and 2 pi factorial. Again, these are curves. If you draw with like sharp corners, I'm going to take off. This is a nice smooth curve. No breaks or corners. So it looks like this. That's one period. Now again, this graph would keep going, so you could extend it both directions if you wanted to. What's the domain of this one? No, it keeps going both ways. We hit everything. The range, what y values do we hit?
-1, 1.
Yep, the exact same thing as sine. All right. So I have a question. Are these functions even or odd? Okay, so this has to do, we did even and odd back in algebra. Even means symmetric to the y-axis. Odd is symmetric to the origin. Is this graph symmetric to the y-axis? If I fold it on the y-axis, does it overlap itself? No. If I fold it on the origin, so first I folded it over the y, and then I folded it over the x, would it overlap itself?
Yes.
Yes. So sine is an odd function. What that means is if you have the sine of a negative angle, that's the same thing as a negative sine of x. We will use this when we go to graph them. We never like to deal with a negative angle. So if you have an odd trig function, you can just pull this negative out in front. That was the definition of an odd function that we had back in college algebra. Cosine. If I look at it, if I fold this thing over the y-axis, does it overlap itself?
Yes.
Yes. That means cosine is an even function. The definition of even back in college algebra is that if you have cosine of a negative angle, it is the exact same as cosine of a positive angle. So what we're getting from this, when we are graphing, if the x is negative, on a sine, you pull the negative out. On a cosine, you can just ignore it and drop it all together. So now we're going back to our notebooks. So you've got this handout. That is all we're filling out on it today. We're just looking at sine and cosine. So in a few days, we will get the rest of them. If I want to graph 2 sine of x and see how that compares to my original. So let's do a teacher. The only points that I told you we really need to plug in are like the quadrant breaks. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you think about the unit circle, those are the points on the x and y axis. So if I put in a 0, sine of 0 is 0, times 2 is 0. Pi over 2, sine of pi over 2 is 1, times 2 gives me 2. Pi, sine of pi is 0, times 2 is still 0. Sine of 3 pi over 2 is negative 1, times 2 is negative 2. And sine of 2 pi is 0, times 2 is 0. When you draw this, okay, the x values on your x-axis, these are quadrant breaks, So space them out evenly. I'm not going to take a ruler and measure those, but if two of them are really close together and then two of them are really spread apart, it is going to throw off your graph and I will take off. So eyeball it, but get them evenly spaced. Those are all like 90-degree intervals there. Okay, so my points, I have 0, 0. Pi over 2 is 2. Pi is 0. 3 of pi over 2 is negative 2. And 2 pi is 0. You know it's a nice curve. Okay. How does this compare to the regular sine graph? It's taller. Our normal sine graph had a high point of 1 and a low point of negative 1. So just like in algebra, we said if you multiply a number out in front, it's a vertical stretch. That's exactly what it did. It made it get taller. Okay. What this is called, if you have a number out in front, that changes the height. So the 2 made it taller. What would happen, do you think, if I put a 1/2 in there?
Make it shorter.
It would make it shorter. That is what is called the amplitude of a graph. So the amplitude, true definition of amplitude is half the difference between the maximum and minimum values. Because sometimes we'll shift our graphs up and down. For our purposes right now, when we think about the amplitude, we can really think we're talking about the height of the graph. And that is found by the number out in front of our trig function. Let's look what happens if I put a 2 on the x itself. So if I make my t-chart. If I put in a 0, 2 times 0 is 0. Sine of 0 is 0. If I put in a pi over 2, sine of pi, 2 times pi over 2 is pi. What's the sine of pi? Zero. If I put in a pi, 2 times pi is 2 pi. What's the sine of 2 pi? If I put in a 3 pi over 2, 2 times 3 pi over 2 is 3 pi. What's the sine of 3 pi? If I put in a 2 pi, 2 times 2 pi is 4 pi. Sine of 4 pi is? Okay, does that mean that this function always equals 0? No, we probably need some more points. What would happen if I put in a pi over 4? 2 times pi over 4 is pi over 2. What's the sine of pi over 2? 1. If I put in 3 pi over 4, 2 times that would be 3 pi over 2. What's the sine of 3 pi over 2? Negative 1. Okay, let's see what's going on here. Again, evenly space out those original 5 points. They're all the same distance apart. Okay, and we got 0 for every one of those. Pi over 2 is like 90 degrees. Pi over 4 is 45, so that's halfway in the middle here. And that gave me a 1. 3 pi over 4 falls between pi over 2 and pi, and that gave me a negative 1. We could keep plugging in points if we put in the next one. This is back to 1. If we put in those, we get negative 1. What happened to my graph? Got your normal sine graph. Yeah, this too is like a stretching and shrinking, remember? So what it did is, instead of 1 period of the graph, how many periods did I just graph? I did 2. It made it repeat faster. It changed the period of the graph. Now, we can, when we graph these, think of the same transformations as college algebra. What we've just seen is they work out the same way. If you put a number in front, it stretches and shrinks. If you put a number inside, it makes it repeat faster. I find, though, that it's a little bit easier to graph this, maybe not thinking transformations, but using some trig terms. If you have a number here, that's what changes the period. So in that case, those have a period of 2 pi over b. We just graphed sine of 2x. 2 pi over 2x, or 2 pi over 2 is pi. It took pi until it started to repeat. So when we graph these things, I'm going to ask you, what is the amplitude and what is the period? The amplitude is the number out in front. The period is 2 pi divided by the number in front of x. So you want to write this down. Okay. So here are the 4 steps for graphing our trig functions. And the rest of the day today, we're just going to practice these graphs. So I am going to make you write down every time 3 things: amplitude, period, and count by. Your amplitude is just the coefficient. Period is 2 pi over b. Count by, we want to split this up into 4 quadrants. So it will be the period divided by 4 for the 4 quadrants. Then we will plot our points and draw in the curve. So y equals 2 sine of 3x. Now you could get this full graph just by plotting points, making a t-chart, but it can become time consuming. I'm going to go through and answer these questions. The amplitude. Amplitude is just your coefficient. So my amplitude is 2. Period. Period is always 2 pi divided by the number in front of x. So that would be 2 pi over 3. Count by. This will give me the points on my x-axis, and you always get that by doing your period divided by 4 for 4 quadrants. Now what that means, that's like 2 pi over 3 times 1 over 4. You get pi over 6. You can use your calculator to get that count by. Just don't put in the pi's. Do 2/3 in parentheses, divided by 4, then turn it back into a fraction. And it'll give you the pi over 6. Okay, now to draw our graph. Amplitude is essentially your high and low points. So I need a high point of 2, a low point of -2. Count by is telling me how to get my points on the x-axis. We start at 0. If you add pi over 6, you're at pi over 6. And we are going to keep adding pi over 6. We want a total of 5 points. Just like when we went around the circle, we had the 4 axes, and we always started and ended at the same spot. So we're going to do 5 points. Again, if you need to use your calculator for this, you can. You just don't put in the pi's. But you just keep adding your count by. So I'm at pi over 6. If I add pi over 6, that's 2 pi over 6, which is like pi over 3. Plus pi over 6, that would be 3 pi over 6, which is pi over 2. Add pi over 6, that would be 4 pi over 6, which is 2 pi over 3. You notice, those are my 5 points. I said my period was 2 pi over 3, and my graph ended at 2 pi over 3. So that's a good sign that I haven't messed up anything. Have I lost anybody yet? Now we are going to fill this in with what the graph of sine looks like. Sine starts at 0. If you look at that one sine graph we started, it always starts at 0, and then does it go up or down? Up. It will go up to its amplitude. So at pi over 6, you'll be at its amplitude. Then it comes back down to 0, down to its low point, and back to 0. So we're just following the pattern for the sine.
So every time be those points?
Exactly. The only thing that will change is, like, if I put a 5 out here, it would go up to 5 and down to -5. Okay. Are there any questions so far? The other thing, I asked you to graph 2 periods. How many periods have I graphed so far? 1. How can I get a second period? Yeah, you can either go the negative direction or just keep adding your pi over 6 in the positive. So either way, this is essentially like the first point, so you need 4 more points following that. If you keep adding pi over 6, this is like 4 pi over 6 plus pi over 6 is 5 pi over 6. Plus pi over 6 is pi. 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. And then we just keep going with the pattern. So we need to go up to 2, down to 0, down to -2, back to 0. And if I asked for 3 periods, you would tack on 4 more points and keep extending it. Any questions there? Let's do a cosine. y equals negative 3 cosine of pi x. Okay. Amplitude. Amplitude is the coefficient, but it is always positive. So the amplitude is 3. What would that negative out in front do?
Push the graph that way.
Say that again?
Push the graph that way.
That's if you subtract 3 on the end. In general, if you put a negative in front, it just flips your graph. So I'm just going to make myself a note that this time we are going to have to flip the graph because there's a negative in front. Okay, our period is how long it takes to repeat. To find it, we do 2 pi divided by the number in front of x. So in this case, it'll be 2 pi over pi. So those pi's cancel and we just get a period of 2. So count by is always the period divided by 4. So 2 over 4 is 1/2.
Why did you divide by pi?
That was the number in front of x. Whatever is multiplied with the x is what we divide by.
So like our last one was
It was 2 pi divided by the 3. Okay. Then we can draw this graph. My high point would be 3 because that's my amplitude. Low point will be at negative 3. Counting by a half, so starting at 0 and then I need 4 points after that. So plus a half is a half, plus 1/2 is 1, plus 1/2 is 3/2, plus 1/2 is 2. How does the graph of cosine begin? Look at the one we drew.
Starts at 1.
It starts at its high point. But we're flipping this one, so where would it start? Yes, we'll start at negative 3. Then it hits the 0, up to its high point, back to 0, and down to its low point. That is one period of this graph. But I asked you to draw 2, so what do? We need 4 more points. Just keep adding 1/2. So that would give me 5 over 2, 3, 7 over 2, and 4. And then keep following your path. Just hit bouncing back and forth between high, low, and 0. Those are the only 3 points we're hitting here on both sine and cosine. Questions there? I am going to do one more, I think. Let's just do one period. Of y equals 3 cosine of negative 2x. Anytime there is a negative, we have to rewrite our problem without it. Cosine is even or odd?
Sine's even.
Which means If you have a negative, what did we write down you can do? We wrote down cosine negative x equals cosine of positive x. So all we have to do is 3 cosine of 2x. And that is because cosine is even. If it had been a sine, what did we write down we would do with the sine? Pull the negative out in front, which would flip our graph when we drew it. Okay, what is the amplitude? 3, period. Normal period is 2 pi divided by the number in front of x, which is 2, and we get pi. So count by. You take your period divided by 4. So pi over 4. Amplitude is 3, so high point of 3, low point negative 3. First point starts at 0, and then I need 4 points after that. And I count by pi over 4. So 0 plus pi over 4 is pi over 4. Plus pi over 4 would be 2 pi over 4, so that's pi over 2. 3 pi over 4. 4 pi over 4 is just pi. And notice that was the period. That's how long we said it would take before it repeated. When we graph cosine, what does it do? Right, starts at its amplitude. So it'll start at 3, comes down at pi over 4, you would hit your 0. Pi over 2, you hit your negative. Back up to 0, and back up to positive 3. And if I ask for a second period, you just keep adding pi over 4 more times. Questions there? Okay. We have just 2 left. I think that covers like 41, 45. So tomorrow I will wrap up this section. I'm probably going to introduce the next section, but you're also going to have some class time to work on this. So it's not all homework tonight. You'll have some class time tomorrow. It won't be due then until Tuesday, because we don't have school Friday or Monday. I might give you a couple more problems tomorrow. We'll just kind of see how things go. So you can start it tonight.